Very good afternoon. Myself, Sumita Sehgal, convener of this seminar, gave a very warm greeting to one and all present here in this webinar. As we know, today, 5th June, is being celebrated as World Environment Day to spread awareness, to encourage people to take action and to prevent the environment. For healthy living, and environment play a key role. Here we will discuss how to resolve the existing pandemic issue to rescue our environment from this dreadful pandemic scientifically. Before we start our webinar with our distinguished guest, chairperson, and of course with our vibrant participant, I would like to introduce my esteemed college. Ma'am, please kindly share the screen. Here you can see on your screen. Now first I would like to tell our founder, tell you that our founder, late Mr. S.N. Kakkad and Professor D.D. Khanna and Mr. Ashok Mole were committed to girl education. They founded the S.S. Khanna Girls Degree College to impart quality education to girls from economically and socially backward section of society. The college started its humble beginning in 1975 and is today a premier constituent college of University of Allahabad. The college have 5 faculties: arts, science, commerce, B.Ed, and of course legal studies. All faculties are doing appreciatively well. At present, also run professional courses in office management and secretarial practices and 1-year diploma course in biotechnology. Now I would like to share the vision of my college, that is, college believe in the teaching of philosophy of unborn too, which means I am because we are. How one can be happy when the other are sad. It has many laurels. It also have many laurels, many feathers in its cap. First is NAC awarded A grade with CGPA 3.46, and at present we are preparing for 3rd cycle of accreditation. It also awarded with the potential of excellency. Phase 2 is going on, and also the Mentor Institute under Paraman scheme of UGC, and also selected for strengthening component of Star College DBT. So next I want to tell you about the strength of my college. Strength, of course, its strong leadership, eminent faculty members, women-friendly environment, financial support and scholarship provided to needy and meritorious students. Beside this, I want to show you some glimpse of my college. Here you can see on your screen. I think it is clearly visible. Now, we move on to the theme of our national webinar, that is relevance of scientific language, values in fighting the pandemic COVID-19 topic. As we know, the entire world experiences the cascade effect of a new pandemic. People everywhere are afraid and in a state of uncertainty. Almost every aspect of modern life has been dramatically disrupted by the disease COVID-19, including health, finance, education, transportation, and community. Scientific finding and projection about the disease, however frightening, at least shines some light into the malicious shadow. All kinds of research resources and products are widely and freely available. The scientific journal and institution are trusted sources of information, yet direct communication from the scientists themselves is an essential ingredient for a better informed people. The world needs more scientists who want to translate their expertise into effective communication on global concern and anxieties. Science could only be a possible mentor to resolve the issue of pandemic. Presentation, meetings, workshop, as well as variety of media platform are now these days are easily possible. The methods to resolve the above issue, or in other words, we can accurately say that science communication is a key in the fight against COVID-19. Keeping all these things in mind, we have invited our speakers and organized this webinar especially for you people so that it make a better communication about the existing pandemic and also resolve the issue scientifically. So now I request Dr. Archana Jyoti to kindly switch on the mic, please. Ma'am, please continue.
First of all, I hope that all of you are fine in this difficult time of COVID-19. When we face difficult times, we should remember that challenges are meant to promote, to increase, and to strengthen us. So, let us welcome the challenges and look for the opportunities in every situation to learn and grow in wisdom. It is a great honor for me to introduce and welcome the chairperson of this webinar, Professor Ramendra Kumar Singh. Professor Ramendra Kumar Singh is a professor of chemistry, director of Bioorganic Research Laboratory, and also controller of examination in the University of Allahabad, India. He has about 30 years of experience in the field of nucleic acid research and more than a decade in the field of antiretroviral research with wide range of training in various national and international institutions. His research interests also include developing natural compound curcumin as anti-cancer agents and fluorescently labeled nucleosides and oligonucleotides as markers in drug delivery. He is a member of several national bodies, editor of different international journals, and referee to more than a dozen national and international journals. He is a recipient of a number of awards and fellowships. Some of these are Fulbright Nehru Senior Research Fellowship of USA, INSA International Exchange Fellowship of New Delhi, Postdoc Fellowship of Ministry of Education, Science and Culture, Japan, UNESCO Fellowship of Japan, INSA Visiting Fellowship, Young Scientist Award, Microbiocides 2010 Fellowship of Pittsburgh, the Tokyo Tech Symposium Fellowship, IUBMP Fellowship, New Delhi, and Jawaharlal Nehru Visiting Fellowship of Bangalore. Sir, I heartily welcome you in this webinar. Today, we are privileged to have an opportunity to listen from our distinguished speaker, Dr. Kavita Seth. She is a women scientist in System Toxicology and Health Risk Assessment Group of Indian Institute of Toxicology Research, Lucknow. Ma'am, I extend my heartiest welcome to you. It is a matter of great pleasure for us that today Professor Anil Kumar Bajpai is present here as a benevolent speaker in this webinar. Professor Bajpai is a professor of chemistry in Bose Memorial Research Lab in Department of Chemistry of Government Autonomous Science College, Jabalpur, India. Sir, I extend my warm welcome to you. In this webinar, about 900 delegates are participating from each and every corner of country. I heartily welcome all of you here, and I am very hopeful that this participation of great magnitude will definitely make this webinar a great success. The presence of Chairperson of Governing Body of SS Khanna Girls Degree College, Dr. Asha Seth, in this webinar gives it a new height. Ma'am, I warmly welcome you here. Our principal, Professor Rajima Singh, has always been a source of inspiration for organizing such type of activities. Ma'am, I welcome you here. At last, I welcome all the people associated with this webinar, especially the members of organizing committee. Now, I would like to request Professor Ramendra Kumar Singh, sir, to chair this webinar. Sir, please.
Hello. Hello. I'm audible to you all, please.
Yes, sir. Yes, sir.
Yes, sir.
Fine. Good afternoon to each and everyone. I feel really very happy that you people have organized this webinar on this day. This day is very important day, very particular day for the whole globe, because we are observing the World Environment Day and we are trying to protect the environment from the bad effects of our progress. We are progressing, no doubt, in all fields, but the ultimate sufferer is environment, and that all the fatalities, all the problems come to us ultimately. So anyway, we'll take care of all these things one by one, and as the responsibility has come to me to chair the session, so our first speaker for this webinar is Dr. Kavita Seth, a famous women scientist from Indian Institute of Toxicology Research, a very famous laboratory of CSIR, New Delhi. It's a very good thing he has graduated from this University of Allahabad. I feel really very happy to introduce her. And she has completed PhD from the same IITR, Indian Institute of Toxicology Research Institute, that is attached from Kanpur University earlier, but now I think these institutes have their own system to provide PhD degree and they can continue with that. So that's a very good thing. Now her field of research is neurotoxicology and nanotherapeutics, and she has several awards to her credit, like from ICMR and CSIR. She has traveled a lot and she has been awarded with several fellowships. The importance is not the travel award. The importance is of the speaker, what the subject the speaker is going to speak, going to communicate. So travel awards are given to very distinguished persons and they have special lectures, they have their own expertise. She has published more than 35 research papers in standard journals, and of course, not much to tell of her lecture. Automatically will express all the things explicitly, I hope. And now I welcome Dr. Kavita Seth, and I hand over the webinar to Dr. Kavita Seth, please.
Yes. Whether the slides are visible, am I audible?
Yeah.
So good afternoon, friends. Today we are here to review the scientific strategies that are being explored to get rid of COVID-19 virus. And the title of my talk is COVID-19 Crisis, Scientific Challenges and Future Perspectives. COVID-19 disease or COVID-19 is a severe acute respiratory syndrome caused by coronavirus 2, that's a SARS-CoV-2 virus. It first appeared in the Wuhan city of China, and within no time, it's all over the world. There are around more than 6 million cases in all over the world and around 200,000 cases in India. WHO declared COVID-19 a public health emergency of international concern, a global threat. So before going into the details of the strategies which scientists are exploring to get rid of this virus, I would like to give you a brief idea of the structure of this virus. This positive sense single-stranded RNA virus, rather a big one and very contagious. It has mainly 4 proteins which is used to get itself replicated and entry in the host cell. So this virus has to enter the host cell to get a person infected and replicate there and then comes out of that successfully. It uses spike protein S1 and S2 to enter the host cell, and it does it by identifying the AC2 receptors which are mostly present in most of the organelle membrane of a system. Another protein which is uses nucleocapsid N, which is responsible for packaging of RNA material. Another one is membrane because it's an envelope virus, very well protected. Then envelope proteins there, which is responsible for assembly and release of this virus. So when it binds to ACE2 receptor, it gets anchored to the membrane by fusion or endocytosis. Once it's inside the cell, the viral genome is released. Translation of viral polymerase protein occurs. RNA replication is there. Both genomic replication and some genomic transcription is there. Then translation of viral protein, structure protein occurs. SEM, all the three proteins combine with nucleocapsid again, and formation of mature virus occurs. And the number of virus copies, they come out to infect, spread the infection. So the first organ which it affects are lungs, and it can do deep damage over there. But the virus or the body response to it can injure many other organs. Scientists are just beginning to probe the scope and nature of that harm. You can see a cross-section of a sac of the lung. A cross-section shows immune cells crowding an inflamed alveolus whose walls break down during attack by the virus. Diminishing oxygen uptake, patients cough, fever rise, and breathing becomes labored. Another organ which is affected by this virus is heart, probably by blood vessels, which do have ACE2 receptors on the cell surface. Infection can also promote blood loss, heart attack, and cardiac inflammation. Next organ is brain. Some COVID-19 patients have strokes, seizure, confusion, and brain inflammation. Doctors are trying to understand which are the directly caused by the virus. In severe cases of infection, the inflammation of conjunctivitis in conjunctivitis of our eyes are there. Another organ is nose. Some patients lose their sense of smell, and scientists speculate that the virus may move up to the nose, nerve endings, and damage cells. Next organ is liver. Up to half of the hospitalized patients have enzyme levels that signal a struggling liver. An immune system is overdriven, and the drugs given to fight the virus may be causing this damage. Next organ is kidney, which are being affected by this virus directly. The virus may attack the kidneys directly, or the kidney failure may be a part of whole body events. Intestine is the next organ. Patients report and the biopsy data suggests virus can infect the lower gastrointestinal tract, which is rich in ACE2 receptor. Again, some 20% or more of the patients have diarrhea. Are you able to follow? Am I audible?
Yes, please.
Then these are the few strategies which scientists are exploring nowadays. So first of all is they are trying to repurpose the already available drugs. So these are the few drugs which they are exploring. First is chloroquine phosphate or hydroxychloroquine. This is an anti-malaria drug with antiviral and anti-inflammatory properties. It works by increasing the endosomal pH, interfering with the glycosylation of the cellular receptors of SARS-CoV-2. It is an immunomodulator. FDA approved this drug in emergency situation in many treatment protocols. Another drug is remdesivir. It is an antiviral drug. It interferes with the viral application. It is also under clinical trials. Then baricitinib, it is already being in use for rheumatoid arthritis. This drug is a AAK1 inhibitor. It interferes with the viral entry by inhibiting one of the endocytosis regulators. This is also being approved by FDA. Then there are three more drugs, lopinavir, ritonavir, and darunavir. These, all of them are HIV protease inhibitor. They could act by inhibiting SARS-CoV-2 protease for protein cleavage, interfering with the virus replication. FDA approved these drugs. Then chemostat mesylate. It is a transmembrane protease serine 2 inhibitor. It interferes with the viral entry, and it is being approved in Japan. Then favipiravir binds to the viral RDRP and reduces its reproduction. It is under investigation. Then safarinide, selamectin, and mefloquine hydrochloride. These all are antiviral drugs with anti-inflammatory activities. They significantly reduce cytopathic effect of SARS-CoV-2 and decrease the viral load. These drugs are also under investigation. Then ivermectin is there. This is anti-parasitic drug. This inhibits SARS-CoV-2 replication veto. This drug is also approved by FDA. So the challenges for the uses of these drugs are that SARS-CoV-2 is actively acquiring new mutations that may enable it to escape the antiviral drugs. Insufficient evidence to conduct a meta-analysis is there. And it's not possible to conduct subgroup analysis because many few reports are there and we don't have much of time. So, and children, different formulation, dosage and fluoridation cannot be analyzed. Efficacy and safety and quality issues are another concern. So in future, efficacy and safety profiles of treatment of COVID-19 will need to be characterized in future studies. Next comes the vaccines. Scientists are trying to prove vaccine from different angles. And the vaccine formulation is a long-term and a very expensive process. And so they are trying, scientists are trying to make whole virus vaccines, subunit vaccines, then nucleic acid vaccines. The few which are notable are this whole virus vaccine by Johnson & Johnson. It is trying to develop an adenovirus phase vector vaccine. Then Podagenics and Serum Institute of India are trying to develop live attenuated virus vaccine. Then University of Queensland are working on protein-based vaccine using molecular clamp platform. Novavax is using recombinant nanoparticle technology to develop a vaccine. Clover Biopharmaceuticals is working on Alzheimer recombinant protein. Then Bayer College of Medicine, Fudan University, New York Blood Center, University of Texas Medical Branch, they are working on coronavirus receptor binding domain protein-based vaccines. Then Vaxart, which is known for its oral vaccine, is trying to develop oral recombinant protein vaccine using VAST platform. Then BJ Advanced Biotechnology is trying to develop DNA-based vaccine. And both Moderna and CureVac are working on mRNA-based vaccines. The vaccine of Moderna has already completed its phase 1 trials and showing very much promise. So there are some challenges associated with this approach also. That is, additional manufacturing steps and formal toxicology testing has to be done, which the undesired immunopotentiation effects of the vaccine should be minimized. The vaccine should be suitable for adult healthcare workers. And it should be suitable for more than 60 years old population or with underlying diabetes or hypertension. It should be suitable for stockpiling. And before coming into the market, this vaccine has to go clinical development. That is phase 1 clinical trials for safety and immunogenicity, and phase 2 and phase 3 trials for both safety and efficacy. So in future, urgent requirement of the effective and safe vaccines are no doubt there. A global security priority to advance and stockpile coronavirus vaccine and to identify international funding mechanism to support their development, manufacture, storage is there. Another approach is development of therapeutic antibodies or passive immunization. One approach is the convalescent plasma option for COVID-19 treatment. In this, the recovered patient donates their blood and the purifying SARS-CoV-2 neutralizing antibodies are purified, and this purified plasma is again given to the patients. So specific human monoclonal antibody CR3022 is recognized. It is a potential therapeutic candidate to address the immediate health threat of COVID-19, and it is effective alone or in combination with other neutralizing antibodies, particularly for the elderly and patients with pre-existing conditions. But this too has some issues. Development of COVID-19 specific antibodies require a long time, limited availability of plasma is there, and passive immunization reduces the aggressiveness and mortality of an infection, but it does not provide long-term protection against the virus. So in future, practicing this method now will help health system be prepared in case of second wave of disease occurs. The Central Drug Standard Control Organization has permitted the Indian Council of Medical Research to conduct clinical trials of convalescent plasma for treatment of COVID-19 in different states of India, such as Kerala, Delhi, Gujarat, Punjab, and Rajasthan. Next approach is use of flexible CRISPR-Cas13 strategy, which is an RNA-guided RNA targeting CRISPR system. It detects and destroys specific foreign DNA fragments. CRISPR with chaperone Cas protein is a powerful technique that has been derived from bacterial defense mechanism. This is a proposed model for Cas13 decleavage of 2019 and COVE. China, US, and Australia reveals that these viruses have different sequences, so this is another challenge with such approach. Only a proposed flexible and efficient approach for targeting RNA till date is this, which can chew up 29 and COVE RNA genome, hence limiting its ability to reproduce. But development of this approach requires a long time. So in future, studies determining the safety efficacy of this system in eliminating SARS-CoV-2 and other viruses in animal model are needed before its therapeutic application to patients. Another approach is artificial intelligence powered tool, which are being used to make the testing convenient. That artificial intelligence is an ability of computer algorithms to approximate conclusions without direct human input. COVID-19 open research data set has been released recently, and AI innovation is working or helping in the major four areas. First is drug discovery, both screening currently available drugs and accelerating process of antiviral development. It is also happening in vaccine development by search algorithms for ligands. Then revolutionizing public communication is there, chatbots are there, which assist in discovery of novel drugs and vaccines and help ease the stress placed on medical hotlines. Then integrative medicine, that is management of COVID-19, help is also there. This is one of the AI-driven drug design platform where people can screen their molecules, scientists can screen their molecules for interaction. This will narrow down their research and save their resources as well as their time. But some challenges are also associated with this approach because artificial intelligence powered tools, they require tremendous expertise. So pharmaceutical companies and basic science laboratories need to cooperate with industry leaders such as Google, IBM, and those have powerful AI capabilities. So in future, people who are receiving false information on these platforms can be redirected to state-approved chatbots to receive effective and valid information. So where we stand now is COVID-19 is currently a major health challenge, no doubt about it. Doctors and researchers work to develop effective preventive measures such as drug, vaccine, developing antibodies, using CRISPR-Cas approach, management with AI. In some people, coronavirus can cause severe illnesses. Factors that affect the risk include older age, underlying health conditions such as diabetes, HIV, asthma, and pregnancy. So until a vaccine becomes available, people can protect themselves and others by following guidance from public health and medical experts. So thank you for your attention. I thank CSR and DST for supporting my projects. Until then, maintain social distancing and stay safe. Thank you.
Okay. Thank you, Dr. Seth. Thank you so much for such a nice lecture elaborating on the mechanism of SARS-CoV-2 invasion and possible strategies, therapeutics, vaccines, plasma therapy, everything, covering all those things in a very precise way. A lot of information you have put in your talk. Now I request Dr. Anuradha to open the session for questions.
Yes, sir. Sir,
Please.
some participants have sent their question. One of them is it true that non-vegetarian food habit has higher risk for coronavirus infection than vegetarian food?
Actually, there's no scientific evidence regarding that. The only thing is that the people think that the meat or non-vegetarian food can contain many viruses. But if it is cooked, then scientists say it is safe.
Thank you, ma'am. Ma'am, another question is, what are the serious drawbacks of excessive use of sanitizers?
Oh,
What are the serious
Sanitizer.
drawbacks of excessive use of sanitizer?
sanitizers are also chemicals which our skin or our system is not used to. Yes, That is, and there is also concerns with its quality and brand. So yes, excessive use, and one has to be careful about it.
Ma'am, most of the participant has put their question regarding use of mask. It is safer to use mask every time.
No, actually, what doctors say, I'm not a medical practitioner. What doctors say that while you wear mask, you could also have that feeling that while wearing a mask, there's some this thing inhibition in oxygen uptake is there, and your CO2 and or whatever you're exhaling is also not going out very this thing so efficiently. So yes, doctors are advised not to wear mask when you are in safe environment, like you are inside the home, not all the time. That is there.
Thank you, ma'am. Thank you.
So it's okay. I think questions are over for this session.
Yes, sir.
Dr. Radha? Okay,
Yes,
fine.
sir. Yes, sir.
So, Dr. Seth, again, I would like to thank you. And I think from Dr. Anuradha, she deserves a big applause also from
Yes,
your
sir.
side, organizer side, for delivering such a meaningful lecture, telling
Yes.
about different processes, mechanisms, how SARS works, this COVID and causing COVID, and different strategies. So many vaccines are in the clinical phases, clinical trial phases. Sometimes one or two. I think they have not moved beyond second phase. Dr. said, right? Just from Oxford University, and one more, they are in a second phase, but not beyond that. So still we have to travel a lot regarding vaccine development. And drugs also, we do not have dedicated drugs for this virus so far. We are just using other drugs, say some malaria drugs, HIV drugs, or HCV drugs. Someone may hit. If it hits, we are in a good position, but we may be at loss also. But the basic, very basic thing about COVID is just maintaining social distancing and stay safe also. Regarding masks, it is already advisory has been given that you need not wear mask all the time. When you are in public place, public contact, talking one to one, just use mask. If you are alone, if you are with family, your family is traveling in a car, you don't need to put mask also. So that way you are safe. Public contact you have to restrict. Mask is for that purpose, to save yourself and save others also. So that's again, I think, gist of the lecture. Thank you so much. Thank you so much, Dr. Seth. Maybe next time we can meet personally once this COVID problem is over and we can discuss the things. Thank you so much. Thank you.
Thank you, ma'am.
Have a good day. Yes.
Yes, sir. You are audible, sir.
Okay. Thank you so much. So first of all, I would like to express my sincere thanks to the organizing committee, principal of the college, Professor R.K. Singh, renowned scientist, and other esteemed speakers. Really, it's a moment to feel pride because I can see Dr. Anuradha Singh, who has been a student of our college in 2005, and now she is organizing and one of the members in the organizing committee, obviously, this webinar, which is focused on relevance of scientific values in fighting the pandemic COVID-19. And at the same time, I would like to greet you all World Environment Day on this occasion. The topic that I have chosen is COVID-19, some updates in cure and prevention. What I will be telling you, I have divided my whole deliberation into three parts. In the first part, a little bit about my institute, as this is the high time when we can share with each other not only our expertise and knowledge, but also about the institution, about where we have been working. In second part, I will be telling a little bit about what updates are going on in the quest for cure and prevention for corona. And in the last, it will be my privilege to share what kind of work we have been doing in our Bose Memorial Research Laboratory, that is in Government Science College. So with these words again, I thank you all and all the audience and the organizing committee, the principal of this college. I was hearing this college was instituted in 1975 only, and in this last 45 years, of course, they have made very remarkable progress, and they have been accredited by grade A by the NAC. So this is really commendable, and I congratulate to all the faculty members and above all the governing body of the college and the principal. Now this is my college where I have been teaching since 1986, Government Model Science College Autonomous, and I am happy to share that this college was founded in the year 1836 as Robertson College in Sagar. Sagar is one of the districts in Madhya Pradesh, so founded in 1836, and its name was Robertson College. Thereafter, traveling a lot, a span of 100 years almost, the college came to Jabalpur and shifted to Government Engineering College building in 1936, and in 1956 the college has moved to the present building, that is that you can see here in this, that is viewable here. So this is the current building or magnificent look of our college. Now a little bit about some milestones. Professor, in our college, there used to be scientific societies, and I am very feel proud to share that Professor C.V. Raman visited the college in the year 1938, and he spoke about the Raman effect having been conferred with the Nobel Prize. When we go beyond this education and come to the field of culture, famous singer Talat Mahmood, he used to frequently come to college. Now, my dear friends, you know very well, it is well said that the history repeats itself. If you remember, in 1920, there was a great spread of Spanish flu, and that was so severe that more than 500 million people gone to death across the whole world. Now I have taken a photograph.
Gone to few slides. I think you can restart or continue as you wish.
Okay. Thank you.
Yeah, please. Yeah.
So thank you so much, Dr. Singh. And really, I regret for the inconvenience and interruption caused due to some problems in network from my end, obviously. So I shared something about our institution, and now let me come to the topic. My dear friends, basically, I suppose that more than 90% our participants, they belong to the students community. So I have made my presentation for them only, and really the lecture delivered by Dr. Kavita Seth was very informative, and some of the information may overlap with the presentation that she had delivered. So always remember that history repeats itself. If you remember, in 1920, there was a spread of Spanish flu, and that killed more than 500 million people across the
आप
world.
फिर से एडमिट करिए अपने आप
Yes, yes. And in I think 18 something, 10 or 15, there was there was a spread of cholera, and that also caused so many thousands and millions of deaths. So again, now this coronavirus has come here. Here I have shared a photograph of a quarantine camp during the spread of Spanish flu. You can see here now, after 100 years, novel coronavirus, it has invaded the whole world, and what we call this virus as SARS coronavirus 2. Now, this is severe acute respiratory syndrome coronavirus SARS 2, and if you go into its profile, its date of birth is supposed to be 17th November 2019. Birthplace, wet market, Wuhan, China, where it was supposed that it has been originated from that wet market and spread all over the world. Now you go through the family tree of this coronavirus. You can see here the first coronavirus, SARS coronavirus, then MERS coronavirus, and the SARS coronavirus 2. This is the current coronavirus that has shown its strength, its power, and how the virus is destroying and killing the population. Now all these viruses are named by, there is a committee, International Committee on Taxonomy of Virus, who is responsible for naming all these viruses. You can see SARS coronavirus 1, severe acute respiratory syndrome. It emerged in China in 2002, and it caused about like almost 800 deaths in 5 countries, and it was not so much spreaded. Now the second virus that belongs to this corona family, that was MERS, Middle East Respiratory Syndrome coronavirus, and it emerged in Arabian Peninsula in 2012, spread in 27 countries, and caused about 900 deaths. But now this time, this severe coronavirus 2 that we call as the novel coronavirus, it has emerged in China in 2019, and lakhs of people have been put into death, and now the data are day by day increasing. How long it will continue, that is not known. Now let us first of all see the structure of coronavirus. Whenever we want to have any medicine or any vaccine or any type of medication, the scientists started looking into the structure of virus, and until and unless we have information or some knowledge about how this coronavirus SARS-2 look like, we cannot go for any medicine or a vaccine. So you can see here, Dr. Seth has already said a lot about the structural aspects of this corona-19 virus. You can see here, there are spike proteins, there are spikes which are responsible for attachment of this virus to the lung cells or human body. So I am not going into very much detail, as she has already spoken excellently on this topic. There was a time image that was published in journal. You can see here, of course, imagination of a virus or something is one point, but experimental validation or its evidence is another point. So the time image of this coronavirus SARS-2 novel coronavirus, it was published, and that I have taken from the internet literature. You can see the shape of the coronavirus that was shown in the last slide and previous slide, and this slide, they are almost same. Now artificial intelligence, as Dr. Seth also spoke about, it also derives some information about the structure of coronavirus spike, particularly the University of Texas Austin and the National Institute of Health Relief. What they did, they took a part of the coronavirus and they went for the cryoscopy electron microscopy. What happens in cryogenic electron microscopy? A part is taken and that is bombarded with a stream of electron, and after that thousands of images are constructed, and from some software or artificial intelligence we derive some information regarding the structure of the coronavirus, particularly the spike part. So you can see here, this is the side view of the SARS coronavirus protein, and this red part shows the receptor domain. This paper was published in Science in 2020, and I have given here the DOI number and the other necessary details. So we are talking about the structure of this spike. Actually, spike is the only responsible part that attaches to the cells and enters the human body, particularly the lungs. So it has been found from research that the binding power of this coronavirus, if we compare with the previous SARS coronavirus one, we find that it can bind 10 with 10 times more intensity with the ACE2 cells, and ACE2 cells. So they are found in the upper surface of the cells, angiotensin converting enzyme 2, and Dr. Seth has already talked about ACE2 enzymes. So this coronavirus spike part, it binds to the ACE2 and enters the human body. So when we compare it with the binding capacity of the old virus, so this virus is naturally severe, and that is the reason so much many times more casualties are there in India also and in worldwide. Now how does it enter the lungs? If anyone person suffering from coughing sneezes, then what happens? The infected is cough, it travels a distance of a speed with a speed of 50 miles per hour. You can imagine if we are sneezing, then the velocity of that sneeze part is 50 miles per hour. And if someone is there and who breathes those droplets, of course this is in the form of droplets and mucus part, the virus can get into the lungs. So here it is shown how does this bind to the cells, to the ACE2 cells, and this is the picture of the coronavirus, and the spike part is are actually the glycoproteins part. Now recently image has been constructed by computer simulation. So you can see here the spike protein is shown in this slide by red part, and ACE2 enzymes on the cells of the lungs, they are shown by the bluish part, and how this spike protein part is attaching or locking with the ACE2 part. And this image has recently been published in a very good journal. Now, nothing to say anything about how did it spread. Like now, that phase has gone, and of course, the scientists, doctors, and these pharmacists, we are chemists, we all are worried how to combat this corona disease rather than talking about its history. Now, let's come to the cure against COVID-19. A lot of information has already been given by Dr. Seth regarding the medicines which are being tried, which are being used, or which are being tried, or which are under trial. First attempt was made by the artificial intelligence. There is a artificial intelligence company, Benevolent, and Imperial College of London. They reported using softwares a lot of drugs which have already been used previously, they can also be helpful in combating this disease. And this paper they got published in Lancet in 2020, and this DOI number I have mentioned here. and on that basis, they have derived some drug structures in silico protease inhibitor and baricitinib. These are the two drugs which they had suggested. Secondly, it was thought by doctors and scientists, is it not possible, can we use the older drugs which were used in the treatment of various diseases previously? Is it not possible to use them again for fighting with the coronavirus too? So attempts were made, and a paper was published by American Chemical Society magazine, and you can see here its GUI number. And in addition to remdesivir that was used in Ebola, a number of medicines like venlafaxine, darunavir, and chloroquine. Chloroquine, I will say something about this medicine just in the minutes to come, and favipiravir. These drugs, in addition to these drugs, penicillin, remdesivir, and other drugs were also suggested for the treatment of corona or COVID. Now, the second drug that is in hot topics or in limelight, that is hydroxychloroquine. Actually, this is chloroquine is anti-malarian drug. This is also anti-malarian drug, but this hydroxychloroquine, this is a little bit less toxic in comparison to chloroquine, and therefore it was suggested for the use in treating the corona. Now, history of this drug. This drug is less toxic form of chloroquine, as just I told you. But before testing it on human or patient suffering from corona or COVID, some experiments were done worldwide. Just to mention, there is a China State Institute of Virology, Wuhan, where this coronavirus originated from. Some experiments were done there, and later on in France also, some experiments were done or some trials were done with this hydroxychloroquine. But what happened? It is very interesting to share, Dr. Singh. I would like to, you can just feel the pleasure of this small story, that a paper was published in International Journal of Microbiology, and just in 7 days. So there were certain case studies which were conducted on just 45 number of patients only. So scientists community, they did not accept it. And it is very interesting that one of the authors of that paper was in editorial board of this journal, the International Journal of Microbiology. So there were some disputes. So we are not going into those what happened or what were the comments of the scientific community. Anyway, the third medicine is the remdesivir. It has also come into limelight, and this Gilead company, who is manufactured this medicine, and it was successfully used in fighting with the Ebola virus. Researchers at the National Institute of Allergy and Infectious Diseases, they also tested remdesivir in monkeys and found that it can prevent the replication of coronavirus. The fourth attempt was made by Emory University chemist. They designed a drug and they called it EIDD2801. And in chemical language, it is isopropyl ester, prototrop, and hydroxycytidine. This drug also showed promising results against the COVID-19 patients. You can see the structure of this EIDD2801 drug, and if you compare this drug with the remdesivir, you find this remdesivir can only be given intravenously through injections, but this drug EIDD2801, this can be given in the pill form. And recently, just last week, Merck company, they have also entered in manufacturing of this drug EIDD2801. Thereafter, a team of scientists found that there are 69 drugs that can be used for the treatment of COVID-19. 41 of drugs were already approved and they were in use, whereas some of the drugs were quite new. Molecular biologist D1 Korengen of the University of California, he identified 332 proteins that SARS-CoV coronavirus proteins bind and replicate inside the human body. This paper was again published in the month of March in 2020 in Bioreactive Journal, and you can see here how did they map it. This is the protein by this potential binding sites, and they are being shown here by the red part. A very latest research that is going on is, can nitric oxide gas fight with corona? You know very well, nitric oxide has played a very important historic biochemical role in 1998, and the researchers were received Nobel Prize for this nitric oxide. That this gas may act as a crucial signaling molecule in the living system. So this nitric oxide, after 1998, it came into the limelight, and our students know very well that if you produce a spark in air, then nitrogen and oxygen, they combine and they form nitric oxide. So that is shown here by a simple picture. Nitric oxide gas was also tested for treating the acute respiratory syndrome SARS epidemic, which was which originated in the year 2002, and very good results were obtained after treating the patients with inflow of nitric oxide gas, and the results were published in 2004 in international journals. What actually happens is that this nitric oxide, when it enters our respiratory system, it boosts the level of oxygen. And still in Canada also, this kind of research is going on, that nitric oxide can be beneficial or not. Then adenoviral vectors, Dr. Seth has already spoken about, so I am not going into these slides. Now let us come to the vaccine. Vaccine is the ultimate solution to that can stop, prevent spread of corona. And you must have read and in the newspapers also and heard in the television also that Moderna, a US-based company, they claim that they have made this vaccine for COVID-19, and they treated 45 patients who received 2 doses of vaccine were given, and they found that the results were very promising and replication of this coronavirus was completely stopped. They use nanotechnology. Those who are working with this field will be happy to know that lipid nanoparticles were used as carrier, and messengers RNA were loaded inside these nanoparticles, and these nanoparticles were allowed to go into the cells. What actually happens? The messenger RNA contains instructions it provides instructions, delivers instructions to our cells to make the SARS COVID protein, that is the spike protein, which the virus uses or infects our cell. So this approach will allow our immune system to make antibodies inside to fight with the spike protein, and only then a permanent stable solution can be found. This is the lab, a picture of the lab where Moderna's lab, where mRNA manufacturing facilities are there in Massachusetts. And what was claimed by the company is that preliminary data from the showed that this vaccine was quite safe and it could very well activate the immune system of the body. So there are certainly some hopes that, and one more thing, that we are thinking that why the vaccine is not coming. Dr. Singh and Dr. Seth, you must know it very well that it takes years to develop this vaccine. And this is the first time, because of the very urgent need, the trials which are performed or conducted on patients, they are being published, and everyone is running behind to find or a vaccine that can fight with the COVID-19. But we are still having a very good, best vaccine that we have, that is quite cheap, easily available, most convenient to use, even a poor can use, very effective. No medicine or other vaccine can be in competition with this vaccine that I am going to tell you, and you know very well it has no harmful effect. Just use of masks, social distancing, and frequent hand wash, and faith in the God. So that will. So these are the simple tips that can prevent the spread of this COVID-19, and that can keep you safe. Just I would like 5 minutes more, Dr. Singh. Okay.
Go ahead.
Okay. So this is just so this part of my presentation is not for my senior scientists and professors who are sitting or viewing this presentation. It is only for the students, so they can see, or they can actually, I suppose that the one of the purposes of such webinar or seminar is to update their knowledge, what is happening there in their own city or what is happening around. So contribution from our lab is known as Bose Memorial Research Lab, and Dr. Anuradha Singh, she has been our student in MSc Chemistry, and really it's a matter and moments of pride for me that she has organized this webinar. Now what we did, we prepared starch nanoparticle. Dr. Singh, we prepared starch nanoparticles, and we loaded those nanoparticles with cisplatin drug and iron oxide, so they were made magnetic. And by the application of magnetic field, we could be able to control the release of cisplatin desirably. When we switch on the magnetic field, drug comes out. When we switch off the magnetic field, drug is inside the carrier. And this paper we published in Carbohydrate Polymer, and Nature India website, anyhow, they came to know about this work, and this Indian website, they published a note that this kind of work has been done in Government Science College, Jabalpur, Madhya Pradesh. In second kind of research, what we did, we coated iron oxide particle with casein protein, and we made core shell nanoparticle loaded with the drug. And what we found that when we apply magnetic field from outside, more than 8 times drug is released in comparison to casein only or iron oxide. And we published our paper in Journal of Nano Biotechnology, and more than 25,000 downloads have been made of this paper. Progress in Polymer Science is #1 leading journal, a review journal, and we published 2 research paper review article, one in 2008, and it is having an impact factor of 26.3. Very interesting case I would like to share, that when the NEC committee came to our college and we told that by the principal, they were told that our faculty has published a research paper of this much impact factor 24. It was 24 at that time. So they started laughing. Are you aware with the impact factor? What is it? So they came to me and asked me and told me that you get a print of that Progress in Polymer Science cover page. We would like to see. So we downloaded it from the internet. So they were quite happy, and they mentioned in their NEC report particularly that this type of good work the chemistry people are doing. We also got a DRDO project for water remediation. We prepared some nanoparticles, iron oxide and some chitosan using biopolymer, and we applied for the patent. and I'm very happy to share that we got this patent in collaboration with DRDO 3 years back. From this, our laboratory, we have published more than 250 papers, 60 PhDs, more than 60, 65, one women scientist, 2 research associate, 8 SRF of CSIR, and 10 projects from different funding agency. More than 80 lakhs have been funded to our laboratory. 5 young scientists, MP Council of Science and Technology, they organized this event on the occasion of the Science Day on 28 March, and in the year 2011, 12, 14, 16, 17, we got this Best Young Scientist Award, thrice in chemistry, once in physics, and once in agriculture. We are also having collaboration with Spain and Korea. Thank you so much for being connected. Thank you.
Thank you, sir.
Well, thank you, Dr. Bajpai, for a very nice, scintillating lecture and information regarding this COVID, its spread, prevention, and other aspects, treatment, and other options. So now, Dr. Anuradha, if there are some students and they have questions, please just
Yes, sir.
put those questions before Dr.
Yes,
Bajpai.
sir. Sir, first question is
Yes.
blood plasma therapy is the best treatment of COVID-19 now?
No. Actually, this COVID-19 it originated in 2019 in November month only or December month only. So hardly 5 to 6 months have passed, and conclusively it cannot be said. Nothing can be said with that this is the best therapy or this is the best medicine or this is the best vaccine. So of course research is going on. You must have heard that in Delhi also this plasma therapy was started, but thereafter All India Institute, ICMR, they put some objection that this is not fruitful therapy. So at each and every front, doctors, pharmacists and the scientists, chemists, they are working on their areas, and until and unless we find some concrete solution of this, so naturally they are carrying out their research and they are reporting their findings.
Next
Another
question.
question is, what effect does the coronavirus pandemic have on pollution and climate change? We see that there is a rapid increase in biomedical waste pollution. Could it lead another disaster?
Actually, there are two different sides of the picture. On the one hand, there were no movements of vehicles. We were not coming out. No industries were running. So naturally, the atmosphere has become very clean. You must have seen the photographs of Ganga and other rivers, how beautiful they are looking. But on the other hand, this biomedical waste, the quanta of biomedical waste that has also increased. So, but that is the demand of the hour, that is need of the hour, so that cannot be avoided. So pollution on this, of course, there has been noticeable significant improvement in the pollution conditions. Environment has become very clean and safe. But at the same time, the other thing that has been questioned about is also there. So there should be a balance between the two, and we should try to keep our environment safe and clean and healthy.
So next question is somewhat controversial. Is coronavirus is naturally originated or biologically designed?
So still nothing can be said. And if you float your some statement, then it has been biologically created. That will be a great dispute. But till now, it is believed that it was spread from the wet market of Wuhan, transmitted from the animal to human, and now from human to human, this virus is being spread. So this is one theory. Now what happens next month or in the coming weeks or in the coming year, that nobody can make any comment upon.
Really,
Sir,
one more
question
thing.
is,
No, wait.
Yes, sir.
Dr. Anuradha, I want to add one thing to this question, or
Yeah.
rather answer. Dr. Bajpai, coronaviruses have very unique phenomena of genome swapping and within the bats. You know, bats are the best host for these
Yeah.
coronaviruses,
Yeah. Bats.
right? So inside bats, suppose two different types of coronaviruses are there, they may undergo genome swapping.
Yeah.
So, and that happens, that is proven. That is proven fact. So
Okay.
if genome swapping happens inside the bat, definitely the third sequence, third genome formed is a new thing. And that third one
Exactly.
is very, very fatal. Probably, I think this SARS-CoV-2 is
Yeah.
the result of genome swapping inside bat. From bats, it moves to animals and then to human beings. So that's how we cannot say, I mean, even some manipulation was there, it was inside bat.
Exactly. Exactly. I do agree with Dr. Singh. Exactly.
Yeah.
Sir,
Next, please.
can humans become infected with a novel coronavirus of animal source?
From animal source. Actually, it has been thought or it has been presumed that it has come from the animal source. So if
Yeah.
they are, if they, in the near future, if some more research is done on this aspect and more kind of animals are proved to be the carriers of coronavirus, so naturally the danger the risk will be more. There will be more danger. So that may happen, but it's still something conclusively may not be said.
That's all?
Yes, sir. Yes, sir. I think that's
Fine,
all.
fine,
Yes, sir.
fine. Okay, that's good. So we are coming to the end of the webinar. And I would like to thank Dr. Bajpai for delivering such a nice lecture, informative lecture, comparing with the other pandemics that happened in future. I mean, that happened in past and in future, I don't know. The things are moving like that. So they may combine and may come in future also. Next generation may face it. A
Yes.
lot of things you have told. And all those, one more thing is there. One thing I'd like to add, of course, you all also have emphasized on that point that all, I mean, different pharmaceutical companies are working at breakneck speed to prepare vaccine, right? So
Yes.
once we get vaccine, we can feel safer. I wish it is easily and quickly obtained. Of course, vaccine development is a roller coaster ride
Yes. Yes.
that goes ups and downs in seconds, and
Yeah.
ultimately, maybe we cannot say phase one is clinical trial, phase one is going fine, two is going fine, third one is disaster. I don't know at what stage it fails, but if it works, we are working for that, and we think I'm also confident we may come out with a certain vaccine. Dr. Bajpai, I would like to thank you for one more thing. In addition to this fine
Yes, sir.
lecture,
Yes, sir.
you provided me a student like Anuradha. She did PhD with me.
We are also proud of her, sir. We are also proud of her, really.
Thank you and your
Yes,
other college
yes, sir.
staff also.
Yes, sir.
Your other college staff also. She has been a very sincere student in my laboratory. Still, she is in touch with me in my laboratory also. She is still having some project works and continuing with those
Very
projects.
good.
In college, she all the time used to praise the college and staff also. So at least I got a glimpse of that today, talking to you and
Thank you, sir. Thank you so
interacting
much.
with you. Yeah. So thank you once again for delivering this nice lecture. And Dr. Kavita Seth also, you are also available on the screen. So I'd like to thank you also once again for delivering nice lecture, and hopefully I wish that this COVID problem is over and we can sit together, discuss together, check out new plans for fighting things. You are also working in the field of drug delivery. Dr. Bajpai also is there. I'm also doing a little bit in the same field, so we can sit together and check out some new plans for research. So that's all. Thank you once again, please. Thank you very much. Thank you. Dr. Anuradha.
Yes, sir.
So
Yes,
yeah,
sir.
now it's your turn, please.
Yes, sir. No, an ignited mind is the most powerful weapon on the earth, above the earth and under the earth. And this is got through your attitude and awareness. Misinformation about COVID-19, particularly regarding its risk to the public, leads to greater uncertainty and fear. In contrast, scientific findings and projection about the disease, however frightening, at least throw some light into the perilous shadow. With these words, on behalf of SS Khanna Girls College fraternity, I take this opportunity to propose vote of thanks to those who have directly and indirectly contributed to this national webinar on relevance of scientific values in fighting the pandemic COVID-19 organized by Department of Chemistry of our college. At the outset, I extend my heartfelt gratitude to the chairperson of the webinar, Professor Ramendra Kumar Singh, for his inspiring mentorship. We are really enlightened with your knowledge and presence, sir. It was indeed a privilege to have Dr. Kavita Seth, renowned scientist. Her insightful lecture was full of information. Further, we are grateful to Professor A.K. Bajpai for bringing his expertise and experience round the table and engaging in such fruitful, constructive, and open exchange throughout. We are thankful to our Honorable Dr. Asa Sheikh, Chairperson Governing Body of the College, for their motivation and blessings. I would like to thank our Principal for his enthusiastic support. Our heartfelt thanks to all the participants. Total 900 registration from national and international platform and across 20 different streams. We hope you all found the session helpful and informative. A special thanks to the organizing committee for their unflinching support and coordination. With these warm words and a kind message, we conclude the webinar. Now, all the participants requested to fill the feedback form shared on different WhatsApp group form for this webinar. E-certificate will be issued only those participants who fill the feedback form. We will be back with you with such more webinar on topics relevant to the present scenario. And for more updates in this regard, keep visiting our college website. Stay healthy and stay safe. Thank you.
Okay. So fine. All is well that ends well.
Yes.
So we had some smaller problems, but we just overcame them, and we have finalized this program. So I
One more
wish you all.
request, sir, from all the participants, kindly open your video so that we can take a selfie or snapshot. I
Okay.
request to all the participants, kindly open your video.
Done?
Yes, sir. Yes, sir.
Okay.
Yes, sir. Yes, sir. Now I'm taking
So
the picture. Thank you.
okay. Namaskar to everyone.